So I know I haven't posted for a while. I did get a few comments, someone asking me if I was going to post, so I'm glad to see somebody is finding these useful. But it's been a busy summer here, and it's pretty short here in Minnesota where I live. But this fall I have been back at it and really digging into VFX graph and shaders and how it works and what it's all about. And I didn't want to post anything that I thought wasn't really useful. There are quite a few videos out there on VFX Graph, a lot showing some cool effects, and I've watched some of them as I've been learning and figuring out how this works. But I found that when I watch them and then I try to do something with them, it's difficult because even though I could follow the directions and do what they do and get the result, I didn't know why I was getting the results and how it all worked. I also found that a lot of effects that are shown make use of exactly how the effect works. Meaning that if I want a ring of fire, yes, there's a torus and I can make something appear on the torus and I can do some simple things to make a ring of fire. It's pretty easy. But what if I want to do something different? And so I would try to do something, I would have something in mind, a particular effect that I wanted to achieve, and found it was difficult because I didn't understand the core components of what they were and how they worked. So I spent some time really digging into it and isolating each component to figure out, okay, how do I do this? And I would demonstrate that. And then I would do a different one, and then I would do a different one, and I had a whole list of them that I then came up with. So now I understood exactly what the components were and how they worked. So in this video, what I'm going to do is first just an introduction to VFX Graph and what it does. Why is it better than the normal particle system? Why would you want to use it versus the particle system? And highlight some of those differences and just the basics to get started so you can really understand what is VFX all about and why would I want to use it, because it is more complicated to use than the standard particle system. And if you are just doing basic particle stuff, maybe the particle system works fine. But if you want to do a little fancier stuff, especially how it integrates in with shaders, which is what I found personally to find most useful to achieve some effects that you just can't with a particle system. So let's dig in and we'll start to go over some of the basics and build a basic VFX graph. And I can kind of demonstrate how some of these core components work. So hopefully through this series of videos, you'll be able to understand those components and be able to use those to put together effects of your own that are unique versus the ones you just see posted online. So let's dig in and get started. All right, so the first thing I'm going to go over is to identify what version of Unity I'm using, because the UI is different, and I noticed that after watching some videos. So I am using 2022 versus 2019. It's like I said, there's a little bit different in the UI, which can be confusing. You do need to have the visual effect graph loaded in. And if we go to the package manager, we can see I'm using visual effect graph 14.0.9, which there may be some differences, not sure. And you need to make sure, and for whatever reason, this has been around a long time, but under visual effects, you need to have this experimental operational blocks checked. So now that we have all that, I also, of course, am using a glow effect on a lot of these. A lot of them do make use of that. And if you want to know exactly the details of how to get that to work, you can look at my video, Why Doesn't My Stuff Glow? Because it took me a while to figure that out myself, even though it's fairly straightforward. So the first thing I'm going to do is talk about just the basic visual effect graph and how to make one. And so we're going to go to create. we are going to go to Visual Effects and Visual Effect Graph, and we're going to call it single rotating, because I am going to show a single particle and show how it rotates. So again, what I did is when I was looking at some of these effects, they made use of some of these pieces, and they go over pretty quick, and when I tried to do it, I missed some of the details, or I didn't quite understand exactly what or how each individual component worked. So I made a bunch of samples and demonstrated to myself that I understood how each one worked. And one method, and if you watch some of my other particle videos of like projectiles, make use of a single particle doing things, whether it's spinning, whether it's doing a trail, lots of other options you have. But how to manipulate a single particle is important, and how to understanding how that works is easiest to see with a single particle. It's not moving. It doesn't have a bunch of other ones in the way. So this can be very helpful. So what we see is our default particles spewing out, as we are all generally aware of how that works. And what we're going to do is select this, and we're going to go to Open in order to edit our particle system. And so what we see here on the default VFX particle system is our 4 components. And the Unity manual does a pretty good job at defining these. I'm not going to go over them in detail. And speaking of the Unity manual, and I have looked at the Unity manual over the years and wondered why it doesn't really help. Why do people watch these videos? Why don't I just use the manual and just read it and figure out how everything works? And I've determined the issue with the manual is it defines what these things are, but not how to use them. And more importantly, how they interact with each other to achieve what you want. And some of the tutorials are pretty nice, but they still cover the basics and really don't help. So what I'm going to do is I am going to stretch this bigger. I have 2 screens, and I recommend, if you can possibly do it, to use 2 monitors, because it's very helpful. Because I'm going to, not going to get over there. I will dock it over here, and let's move this a bit. Scroll this so we can see both at once, and zoom in a bit. So by default, we see our default particle, and I'll talk about the default particle too and why it looks like it does, which is another thing it took me a little while to figure out. It's like, what is so special about this particle, and how is it helping me, and what are those green and red lines, and everything. So as we get to the rotation, I will talk about that a bit. So what we want is, we don't want to use this constant spawn rate. So I'm going to select that, and I'm going to delete that. And instead, and as you can see here, it says press space to add blocks. Very handy. I'm going to press my space bar, type in single, and I'm going to do a single burst. And I'm going to do 1, burst of 1. Then what I'm going to do is, I don't want a velocity. I want it just to sit there and not move so I can see it. And I don't need a lifetime. Basically, I want the lifetime to last forever. And so I'm just going to delete the lifetime. So we initialize it. It's going to create 1 particle. And I'm going to grab this guy, and you can drag it up. You can drag these squares around any way you like to give more or less room. And what I'm going to do is, we don't see anything for a couple reasons. One, I am going to not orientate the face toward the camera. So remember, particles are flat. They're basically PNGs. Usually they're an image, and so they're flat, and so they have no thickness. So you really can't see the side of them. So sometimes, a lot of times, you want the flat part to always face where the camera's facing. I don't need that, because I'm going to actually manipulate the rotation. I don't want to set the size over life. I don't want to set the color over life. So now we start to see something. We can zoom in. We can see a little particle sitting there. And he's at the 0 point, which is at the center of the particle. And he's not facing the right direction. So what I can do is I can select him, drag him up. But he's still pretty small. So I want to make him bigger. So I'm going to press space here on the output. And I'm going to say set size. And I'm going to make that size 1. So now he's bigger. That's better. Bring up a little more. Now, what is all this about the green and red lines and the blue square in the middle? Well, when we're setting the rotation on these particles, it's localized to the direction that the particle is facing. And the red, remember when we select this, right, we see a green, we see red, and we see blue. So red is the x-axis, green is the y-axis, and the blue square, of course, is the z-axis, which is coming out from here right now. Because you'll notice, right, this aligns with the z-axis, the y-axis, and the red axis. So that is why these lines appear on the particle, to help you visualize what the local coordinate system is on the particle that we're working with. So what I'm going to do is, when we initialize the particle, what I want to do is I want to set the angle to it, because I don't want it being facing this direction. So we are going to set the angle, and we are going to rotate around the y-axis 90 degrees. So you'll notice right now the red is going to the left. We select this. And so we're really kind of looking at the back. So do we do negative 90 or positive 90? Well, it depends. It is flat. It looks the same with the back or the front. In this case, you can't tell the difference, but if you have like a flame or something that you want, or something that is different directionally, you need to pay attention to that on which way you rotate it. So you're not looking at the back. So now what I want to do is I wanted this to rotate. And so every time through the loop, and I haven't really dug into this, is how many times does it call update per second? I have not found any specific information on that, or how to set that rate. I guess there's the rate, you know, when you've selected this, there's a rate that shows up on the screen that you can't see it right now. I haven't looked into how to set that rate programmatically, or change that rate other than 100, and what 100 means. Is that 100 times a second? I haven't really tested that. And it may depend on what else is going on in your game. So, but when we update the particle, what I'm going to do is I'm going to press space bar here, and I'm going to add angle. And what I want to do is I want to rotate around the z-axis. Remember, the blue, the z-axis is pointing out. It's perpendicular to our particle right now. So if I do 0.2, you'll notice it is rotating. And now the question is what is positive direction? What is negative direction? Is positive clockwise or counterclockwise? You'll notice right now it's going counterclockwise. And I don't know if that means I'm looking at the back. If I change this negative 90 to 90, you'll notice now it's going the other way. So the combination of which way I've rotated it, am I looking at the back or the front, and whether this is positive or negative, you can control the rotation of your particle. So now what I have is I understand how to rotate my particle. This set angle is going to rotate it, and this update is going to modify the angle of its and actually make it rotate, because I keep adding every time through the loop. I keep adding right to this rotation. And so if I change this to 1, it's going to rotate a lot faster. If I change it to something smaller, 0.1, it's going to go a lot slower. So that's the other thing I would suggest, that if you're trying to understand something, you have to be able to modify the component's values and have it react how you think it's going to react. If it doesn't react how you think, then you don't really understand how it's working. And I've been programming a long, long time, and whenever I'm coding and I don't understand something, part of me says, well, maybe this number will work, and I try it. And I always call it, playing the slot machine, right? Slot machines, you put in your money, you pull the handle, and you hope for the best. Is it going to come up cherries, or, when I win, or am I going to lose? And that's what you can do on a lot of these things. Maybe this number will work. Pull the lever. That didn't work. Maybe this will work. Maybe this will work. Trust me, it never works. Because even if you get it to work, you don't understand how it's working. And then when it stops working, and it may very well stop working, you have no idea why. And it can be very frustrating. So starting small and simple, saying, okay, I have a particle. I understand how to rotate it, right? Set the angle, initial angle, and I understand how to modify that angle dynamically every time through the loop. All right, so now that we got one, and now we understand, right, the green and red lines. So which one of these angles do I do? I could just guess, but see, now I understand it. Oh, I did the Z because the Z is coming out at me. This little blue square is the Z-axis, right? And when I initially did this, I understood, oh, this green is the Y-axis, right? So if I did this to 0, let's blow this up a little more, and I did the Y-axis, right? It's going around that green line, right? The Y-axis. You can see that it's now, if I do X, no, unfortunately it's all messed up. And the other thing is that, see, you notice this little local? If I change that to world, then it is going to do all the rotation, right? It's not going to use the local coordinate system, meaning the local coordinate system changes as I set this angle. The world coordinate system does not. So that's one thing that you also have to pay attention to. And in some of these videos, they may not point out, and they may just click it really fast and you didn't notice it. And that's another thing to make sure you look at. Okay, so now that we have this, what we're going to do, the next thing we're going to do is look at where the particles are launched from. Because the one thing VFX Graph gives us is I can not only have them launch from a single point, but I can have them launch from various shapes, whether it's a cube, whether it's a sphere, a torus, or a plane, or even a whole mesh. And some of the cool effects they do by having the particles appear on the whole mesh. So let's take a look at that next. So the next thing we're going to do is we are going to use some of the new functionality that controls the position of where each particle is created. So what we're going to do is we're going to make all the particles appear on a torus. So let's go to our video samples, and we're going to make a new VFX graph. Let's go down here, visual effects graph, and we're going to call it torus rotating. We'll see that why in a minute. So we're going to open this up. Well, first of all, let's drag her on here so we can see our default particles coming out like before. We're going to select this. We're going to open it. And I'm going to drag it over here. Right, just like that. give it some room. Where'd it go? There it is. I'm gonna zoom up here. And what we're gonna do, a couple things first. We are going to get rid of this set velocity. We're gonna get, we can leave the lifetime. Going to get rid of that set orientation because we're going to control the orientation. We're going to get rid of that set life, set color. And then what we're going to do is in the initialized particle, we are going to add a arc torus as the controlling where'd he go? He's really small. There he is. All right. The particles are really small because I haven't set a size, and the default size is pretty small. So let's set a size. Let's make it 1. All right. Pretty big. All right. And then what we're going to do is, since it defaults to vertical, I'm going to rotate -90, and I'm doing it -90 so Z is up. Otherwise, it would kind of look upside down. All right, so we have all our particles now just appearing and then not moving and disappearing on the torus. So if we select our torus here, we can see it highlights the controls. And this is one difference. I told you I was using 2022. 2019, this works a little different. Nope, I want to leave that the same. I want to grab the center to make the radius a little bigger. All right. Let's make this a little smaller. They're a little big. 0.7, that's better. I'm going to get some more space here. All right, so we have our items appearing, but what I want to do is I want to make them move around in a circle. So I want to set their velocity, but the thing is I don't want to set the velocity just in one direction. I want to change the velocity's direction as it moves around the circle. And what is the direction I want to change that? What I want to do is I want to change it perpendicular to a vector from the center point of the torus to the current position of the particle. So you can imagine if the particle was here, I'd want the direction to move in this direction. If the particle was here, I'd want it to move in this direction, and so on as it goes around the circle. So there's a function that can get us the perpendicular vector to another vector, and that's the cross product. And if you look up cross product, you can see that it will give us, given of two vectors, it will give us a vector perpendicular to that. And they've given us a way of getting that. So the first thing I have to do is I have to take and I need to find this vector. It's really, I want to find the direction between the center point of the torus and the position of this vector. And if we look at our, let's zoom in a bit, if we look at our arc torus, we can see that we can get the position of the torus, but all these are inputs, and I need to get the position as an output. So what I'm going to do, just going to zoom out a bit here, is I'm going to add a node, which is an arc torus. And the reason I'm doing that is I can get the output of this arc torus. And what I want to do is I want to make this arc torus, just collapse that down again, be this arc torus. Oops. There we go. So now whatever I do on this Arcturus, you'll notice that this Arcturus has a different radius, so you need to change the radius of that Arcturus. So basically what I'm doing is all these values you see they grayed out because now they don't matter anymore. And now what I can do is I can take the output of this Arcturus, let's expand that, let's get the position. And what I'm going to do is I want to take the position of the current particle. So how do I get the position of the current particle? So what I can do is I can create a node, get attribute, right? So I want to get the attribute of the current particle I'm working with, and I want to get its position. Scroll down here. And what we want to do is we want to get the position, the current position. Where is it? There it is. And I want to get the current position. And what I want to do is I want to subtract the position of this from the position of the current one. And that will get us the vector, the direction between the center point of this and the item itself. So I will say subtract. I'm going to subtract it from that position. So if this gets a little small, but I need some more space here. And so now I have the distance, but what I want to do is I want to normalize this vector. And the reason I want to normalize it is I really want to use just the direction. And as we change the circumference of the Arcturus, we are going to make that vector longer. And I don't want all my other values to be affected by the distance. I just want the direction. And so that's what the normalize does. It makes the vector exactly 1 unit long. And so that makes it easier to work with, and I don't have to worry about the length of the vector. And now what I'm going to do is I'm going to take the cross product. And again, and I'm going to take the z value of the cross product. Now, you could sit down, and I did not sit down mathematically to figure out which vector direction that I wanted to do the cross product. There's only 3 choices, and I know I said before not to kind of guess, but the fact is that doing the math can get kind of complicated, and since there's only 3 choices, it's pretty easy to do a little trial and error on that. So now we got the cross product, and I am going to want to take that. I can now take that cross product and hook it directly up to a velocity. I want to basically change the velocity dynamically. I'm going to move this a little closer. All right. So what I want to do is I'm going to go in here and these are overlapping now. Here we go. Got to get our output visible here, and I'm going to set the velocity. And the velocity that I want to set is going to be the cross product, because the direction, right, that I want it to go, I want to keep changing the velocity perpendicular to the position that it was. And you can see what's happening is they just start moving because the velocity continually changes every time the particle moves and is updated, which causes them to move around in a circle. Say right now they're going counterclockwise. If I wanted them to go clockwise, I could simply negate this cross product, or I could, let's see if I do -1, what happens? If I change the direction of the cross product, now my particles are moving in the other direction. So simply by changing some of these values, I can affect how they move. So what we have right now is a nice effect that we could use. So if I wanted a swirling effect that was just flat on the surface of my scene, I could use this I could use this particle system, and if I instead take that cross product and multiply it by a value, I could affect the speed, and I'm not going to go over that right now. I'm going to do that in a little later videos. I can make visible the attributes inside of my particle system to my outside object. And we'll see that in some later videos of how you can kind of tune all the values that are affecting your particle system, because how they all come together, and when you get lots of particles and they're moving all in different directions, it's kind of hard to visualize how that's going to look. And so you can expose all those, which is a great way of tuning up the look of your VFX particle system. So we have a nice torus, and they're going flat. But what if we want to do something a little different? So what I'm going to do is I'm going to make a copy of this, because I want to keep this one, and I'm going to rename it torus rotating flat, because it's a useful system. And I'm going to duplicate this, and I'm going to change this name, and I'm going to say torus rotating up. So we'll show what I mean by that next. So let's make these things stand up on end and go up, so we could make like a column of rotating particles instead of just something that's flat. So let's take a look at that and make that work next. All right, so let's just gonna turn this one off. See, by unchecking this, I can just hide that. You can see I have a lot that I have hidden over here that I've made over time. And what we're gonna do is we're gonna grab our torus rotating up, and we're gonna drag him on. And we're going to rotate him by our -90. So we basically got an exact copy of what we were working on before. And what I'm going to do is I'm going to select that guy. I'm going to open him up. Let's hide him. So what we're going to do is, what we need to do first is I don't want them laying flat. I want them to stand up on end. So how am I going to do that? What I want to do is change the angle. Remember when we were working with our single rotating particle, we saw how we could change the angle of our particles. So what we're going to do is we're going to stand this guy up. So what we need to do is, again, we want to have his angle be perpendicular. Again, change with the perpendicular of that normal vector from the center point to its position. So you'll see what I'm talking about in a minute. All right, so let's zoom up here. And what we're going to do is in the update particle, we're going to add another block. Let's make it a little smaller. Let's get some more space here. So you can drag him off like that. All right. In the update particle, let's add another block. And what we're going to do is we're going to do set angle. All right. So what we're going to do first of all is set that angle. We are going to change the Y value to 90. So what that did is it stood up all of our particles, but they're all still facing the exact same direction. And what I want is I want the direction to change because I want the face of it always to face the center of our torus, right? So what am I going to do? What I'm going to do is I'm going to take my same cross product and I'm going to use it to set the angle. And if we look at this, we can see the X, remember that red and green line, the X position, the local X axis of my particle, I want to rotate around that x-axis, and I want to rotate around the x-axis by the cross product, the same cross product that we're using for the velocity I can also use for this. So if we come down here and we expand this angle and I hook it up all right, so it didn't change. And the reason it didn't change is the cross product is a number between 0 and 1, right? And the angle is between 0 and 1, 360 degrees. So I need to convert that to something between 0 and 90 because I want to go 90-degree rotation, right? When it's here, it needs to be rotated 90 degrees. So what I'm going to do is I'm going to multiply this by 90 and see what we get then. Instead. All right, well, it is rotating around the x-axis, that's correct, but it is, what is it doing? Well, the problem is you'll notice in this direction it's correct in this quadrant, but in these other quadrants it's spinning around because it is trying to convert. Remember when we cross the 0 point, when it goes from 0 to 360, that's a problem. And so it's kind of hard to explain, but essentially when this vector, the x component, is positive, I need to multiply it by 90, and when it's negative, I need to multiply it by negative 90. One or the other. I'm trying to remember which is which. So what we need to do is we need to take this normalized vector and we need to do a branch. We need to do a compare first. So what we need to do is if this is less than 0, we do a branch. It's basically a conditional. Remember, all of these are just going to code, so this is basically doing a conditional or an if. And so what we're going to do is if it's true, we're going to do 90, and if it's false, we're going to do negative 90. And it took me a while to figure out all these values. And again, it would take a long time to go through all the mathematical explanation. So then what we're going to do is we're going to take that value and feed it into this. Instead of always doing 90, we are going to do it that way. All right, so if we look, it's still not quite doing what we want, right? It's still spinning. And the reason is that this compare, I really wanted to say less than, not equal. So then basically if it's less than 0, meaning it's in the negative direction, it is going to do the 90. If it's greater than that, it's going to do the negative 90. So a couple things. One, it's still flipped. It's this red one is pointing down and I really want it pointing up. So let's do a 180 on the Z. Okay, now it's pointing the right direction. But now you see the green is pointing to the right, and you'll notice as soon as it flips this point, it flips around to the left. And that's why it helps to see these lines here. Otherwise, we wouldn't notice that that's happening. And essentially what we're doing is we're flipping it to the front, to the back. You know, I played around with this, and it's tricky because of how the cross product works, but we can get around that by doing another conditional branch here. So what we're going to do is come down here, make another branch. And what we're going to do is if it is greater than 0, we are going to do an add. Basically what we want to do is rotate it 180 degrees if we are greater than, if it's in the positive direction. So we're going to do an add, and we're going to add 180 to that X rotation. Actually, we want to add the branch. So that's not that. We want to add the output to this, to that. Let's move that over, make some room, feed this into the X. And now what we see, it's pointing to the left, pointing to the left, pointing to the left. It's always pointing to the left, right, as it goes around. So it's always going to be pointing in the same direction. It looks like it's pointing to the right because we're actually looking at the back, right, as it reaches the back of the circle. But essentially what happens is whatever image we use will always be pointing in the same direction as it goes around the circle. So that's really what we want. So now we've got a simple torus. It's rotating around, and our image is going to be pointed up. So now we have our torus flat, and we have a torus spinning standing up. And for the next videos, what we're going to do is go over how we can use this in order to achieve some effects by combining some shaders and a specific image that we can fade and make some cool looking effects using our torus. But first we need to understand exactly how to control our image, and using the default particle here, it really helped us, right, with those lines. So now you can understand why we have a default particle, how it helps us see that what axis we're dealing with, and this rotation can be pretty confusing, and that really helps us. So stay tuned for my next video, and we'll make some more interesting looking effects than just our standard particle.